Ever wonder how your computer actually works, or even if a career in tech is for you? Well, this is where it all starts. Welcome to Tech 101. Hey, I'm JR, an IT professional with a bachelor's degree in cybersecurity and 8 industry certifications. I have over 16 years of experience in the government healthcare industry, and over 7 of those specifically to health IT. Tech 101 is a 4-part intro course into IT, and it's designed to give you a solid foundation in IT concepts and terminology, infrastructure, application, software and databases, and security fundamentals. By the end of this series, you'll have a clear understanding of IT fundamentals, so you can decide if tech is the right path for you. If that sounds good, give the video a thumbs up and stick around. You won't be disappointed. Now let's get started. Okay, in this first video series, we're gonna actually be covering IT concepts and terminology. So here is what we're gonna be diving into. You're gonna learn today what is IT, basic computer and components, types of computers and devices, data basics, and the troubleshooting mindset. I've also leave timestamps in the description for easy navigation, so feel free to skip around or just revisit some of the topic as you see fit or as you need. So what is IT? Information technology is the use of computers, networks, and systems to store, manage, and process and transmit data or information. IT is everywhere, from healthcare to banking to social media, streaming services like your Netflix, gaming, and everything else that you can think of. We use IT every single day, whatever it is you're gonna order food from Uber Eats, or watching this video right now on YouTube, you are actually using IT. But how does these computers or IT systems actually work? To understand that, we need to break down basic computer components. But real quick, a little bit of history. Computers originated in the 1940s, with the first general purpose computer at the ENIAC 1945 being a massive machine that filled an entire room. Over the decades, they have evolved from room-sized machines to desktop, laptops, and even powerful smartphones that fit in your pocket. As you can see here, that is a pretty big machine right there. So, but the fundamental concepts are, computers have hardware and they also have software. So a hardware is actually the physical components of a computer, the things that you can actually touch. And software is just the program and applications that run on a computer. So in this section right now, we're going to be focusing on hardware, since software will be covered in another part of this course. So later on, okay? So key components of a computer. So as you can see here, the CPU, right? So the CPU is the brain of the computer. You can see this as CPU here, or a picture of a CPU there, right? So the CPU processes instructions and performs all calculations necessary for a computer to function. The speed of a CPU is actually measured in gigahertz, essentially how many billions of instructions it can process per second. That's what that means. There's different brands like Intel and AMD. Those are different companies that actually create CPUs. You also have for mobile devices, Snapdragon and the M series from Apple. So the higher the gigahertz is, the faster the processor can actually execute a task. So when you're looking for a CPU, you're looking for something that has higher gigahertz, if that makes sense, okay? And as I mentioned, the CPU come from different companies, and just a few of the PC's models for CPU for Intel, the Core i7, i5, i9, from AMD, the Ryzen series, and then of course the mobile processor like Qualcomm, the Snapdragon is Qualcomm, and of course the Apple, right, the M series. So number 2, we got random access memory, or RAM. They also call that the short-term memory. So RAM temporarily stores data that the CPU actively uses, keeping the system fast and responsive, right? So unlike storage devices, the RAM is a volatile memory. They call that volatile memory, meaning when you shut down the computer, your RAM actually wipes away. That's what volatile means. RAM have different sizes, and they vary from 8 gigabytes to 16, 32 gigabytes. And The more RAM that a system has, the more tasks it can handle at once. So yeah, just pretty much in short, that's what it is. We'll cover what gigabytes are later, so just stay tuned for more. So number 3, we got storage or long-term memory. As you see here, there's 2 type of storage devices. You got the hard drive. It's a traditional storage with spinning magnetic disk. It's more affordable and they have a pretty large capacity, even though nowadays the SSDs, the smaller versions, they also got big size or very large capacity. Now, a con, I will say, from these is that they got slower speeds, plus it will be this more affordable, I guess. So the other part is going to be the SSD, the solid state drive. So this is M.2. Normally these are seen in laptops. There are different models of SSDs that you can find around. Benefits is that no moving parts. It's actually faster. And one of the cons or negatives, I should say, is more expensive. SSDs are definitely more expensive than the regular hard drives. So while the hard drives are still used in budget systems and for high capacity storage, most modern computers, they now come with SSDs, similar to this one. Now you might be thinking how all these parts work together. So enter the motherboard. This is the backbone, right? The board is a large circuit board that connects all components together. CPU, the RAM, storage, power, peripherals, it means that USBs and graphic cards and all that good stuff, right? So think of it like a highway system. It allows different parts of the computer to communicate and function as one system. Without a motherboard, none of these could communicate. It's what allows the CPU, the RAM, storage, and peripherals to work together as a complete system. So pretty much, a motherboard is really integral to the system. So let's go. Next one, we got the power supply and cooling. And pretty much this is what keep the system running. This is a picture of a power supply right here. It pretty much powers everything. Power supply, right? It provides the power. And this is a picture of cooling system with some fans. There's also liquid cooling. There's heat sinks. There are different things that you can do nowadays to the computer. So as you guys know, computers run on electricity, but different components require different voltages, right? So there's different type of PSUs or power supply units. And what it does, like I said, just powers everything. And there's definitely multiple ways of cooling a computer. So without proper cooling, computers will overheat and slow down. And, you can even shut down, damage, and burn something else in your actual machine. So other components or some of the key mention that I should put up here. We're talking about GPUs, right? So GPUs, these are graphic process units, or it pretty much is a dedicated card to have your graphics be a little bit better in your computer. Nowadays, you can really achieve some great things, like gaming and other great things with these bad boys right here. And the NIC, or the network interface card, is what actually permits your computer to have an Ethernet connection and connect to other computers, connect to the internet. There's also wireless cards that makes your computer, your laptop, be able to connect wireless to a wireless signal. We'll cover a little bit more later on the series. So wrapping it up, these 5 components and these other additional mentions are the core fundamentals of every single computer. Now that you understand what is inside a computer, let's move on to the different type of computers and devices in the next section here. Okay, computer come in many shapes and sizes, each designed for different purposes, whether you're using a personal laptop, a powerful business server, or a cloud-based system. They also function in the same basic principle that we just covered. Now, moving on, there's 2 types of computers that I'm going to cover here. We got your laptop and we got desktops, right? So laptops are portable, battery power, and it's ideal for working on the go. You're probably watching this video on a laptop. I am actually using a laptop to present this training. And a desktop, normally powerful. Even though you can have some pretty powerful laptops, you can have pretty powerful desktops. Now this one is actually, you can upgrade it and make it for gaming, even though there's laptops for gaming too. Desktops are most used by people with a game and edit videos and things like that. Nowadays, you can interchange. So in reality, this is just portable, and this one is just your house and big one. So now I got a fun fact. While desktop typically have better performance per dollar, laptops have become the go-to choice for professionals for the convenience and portability. Now moving on to the next one here, we're talking about servers, right? So servers are the backbone of the internet and businesses. A server is pretty much a powerful computer designed to store, process, and manage data for other computers. Server handles website, emails, cloud storage, database, and corporate networks. They don't look like regular computers. Most are rack mounted, and they happen in data centers all over the world, and they're built for 24/7 operations. So when you visit a website, you're actually requesting a data from a web server, and then that process you request, it delivers that web page to your device. It's just everything happens in milliseconds pretty much. I hope that makes sense. So let's move on to the next, computing. So cloud computing, everything online, right? No physical hardware needed. And there's actually two main places that you can store your data, right? So you got your cloud and you got your local storage. So local storage pretty much means your computer's hard drive or your solid state drive or SSD. And cloud storage, it means that it's remote on a server, access over the internet, right? So you don't have it physically in your house. Instead of storing the data and running applications on your actual personal computer, cloud computing allows you to access services and data remotely via the internet, right? So an example I can give you would be Google Drive. Your Netflix is hosted on a cloud, Dropbox, your email, OneDrive. There's even gaming now that you can do in the cloud, right? So most companies, even individuals, they actually use both for flexibility and for protection. You can store a portion of your stuff home and their other stuff at the cloud. Think about it like maybe at home you have a backup of your pictures, and then in the cloud you have another backup of your pictures. I mean, something like that. Those are just some examples of what cloud versus local storage is. Now, businesses rely on cloud computing for scalability, security, and cost savings, making it one of the most important IT advancements in the 21st century. So let's move on. So the next one, we'll talk about mobile devices. So phones, tablets, IoT. So, smartphones and tablets, mini computers in your pocket, pretty much. They run mobile operations. They run on iOS if you have Apple, Android if you have Android, Google, or a Samsung device. And, they can handle calls, text, gaming, productivity apps, and everything in between. IoT devices, smart watches, smart TVs, smart thermostat, and even some refrigerators nowadays. They can all connect to the internet and making them smart, I guess, and collecting and sharing data everywhere, pretty much. Okay, so now I got another fun fact. Your smartwatch has actually more processing power than the computers that sent the astronaut to the moon in 1969. Let that sink in. Just saying. So from personal desktops and laptops to massive servers running the internet and mobile devices to the cloud, computers have evolved to fit every aspect of modern life. Now, let's just check out what makes these devices functional. Okay, so data basics or data, binary, file types, storage sizes, and you see a lot of zeros and ones here. Now, let's talk about that. The real star here is going to be data, right? Everything you do on a computer, from sending a message to watching Netflix, is actually made of data, right? Data. But here's the part blows most people's minds, right? Computers only understand two numbers, the zeros and one right here, right? Binary system, 0 and 1. The letter A in binary is this right here. Thousands of or millions of zeros and one packed together. Let that sink in. Crazy. On or off, like a light switch, on and off. So imagine millions, billions of switches just twitching on and off, on and off. That's what represents images, sounds, everything. So it's wild when you think about it, right? So it's to me, it's just like, I'm not gonna put the meme here, but right, because that's how computers actually work. Okay, let's move on. Let's talk about how the computers recognize your work. So let's break down just a few basic file types that you're gonna run into. .docs, it's a Microsoft Word document. .pdf, portable document format. You can see that Adobe, and I think Adobe is like the most famous PDF, but there's different type of PDF. That's just a file type, right? You got JPEGs, which is image files, MP4s, and or .mov with video files, .exe, .app. So there's programs, executables, and applications. So each file type is formatted in a specific way, so your computer knows what to do with it. So if you try to opening JPEG in Microsoft Word, that's really not gonna work. So they are formatted a specific way, so your computer knows what to do with it, right? So those are the common file types. Okay, now let's go to storage sizes. I know I covered a little bit of this before. So how do we measure this data? We were talking about gigabytes, because those files that we just mentioned, those file types, they have a size, right? So here's the breakdown. 1 kilobyte is about 1,000 bytes. 1 megabyte is 1,000 kilobytes. 1 gigabyte is 1,000 megabytes. 1 terabyte is 1,000 gigabytes. And it keeps going up after that. So some real world examples is a Word document, maybe it's 100 kilobytes, high resolution photo, 5 megabytes, even a little bit more now. Full length HD movie, 2, 3, 4 gigabytes. And a modern laptop nowadays usually comes with 256, 512 of gigabytes of storage. And that RAM that we mentioned earlier, some of them got, 16, 32, or 64. In my case, I got 64 in mine. So it depends, right? So just to recap, right? All digital data is built from binary. Data is stored as files, and each file is a different type. And then we measure all that files and all that data in kilobytes, megabytes, gigabytes, terabytes, etc. So is that simple? Okay, now that we covered data, we're going to shift gears real quick. We're going to talk about something that separates beginners from the IT pro. And this is the troubleshooting mindset and how the pros solve the problems. So here's a little secret. Being great in IT isn't about knowing everything. It's about knowing how to solve problems when things go wrong. That's actually what separates from somebody that actually Google the fixes or somebody that actually knows how to fix it, if that makes sense. Now, quick disclaimer. I'm not saying that Googling something is actually wrong. All of us do it, right? Sometimes we just need a reminder how to fix something. So don't come at me with pitchforks and stuff saying that, oh my God, you're not supposed to Google stuff. No, you can still Google stuff. I'm just saying that sometimes we just need a reminder, right? It's different than actually just trying to figure out by Googling it. And sometimes that's the way you do it, right? Now, where something breaks is when the IT pro approaches this stuff. They identify the problem. They ask, what is not working? It is the entire system or just one app? When did it start, right? They gather the information. Are there any error messages? Did anything change recently? Like a new update, a new software, or something? Can you recreate the problem, right? Then you try a solution. You start simple. You just restart the devices, check your connections, reinstall the software, look up the error code. And yeah, those are the basic things that you do. And then you test and confirm whatever you apply, did it work? Right? Is the issue gone? If it is, great. If it not, just move to the next possible solution or just escalate. There's no problem with escalating. If you need a friend, you get to phone a friend, you can phone a friend, right? And the last thing you got to do is document it, right? If you're in a job, usually document what happened and what it fixed it and what were the steps taken in order to resolve that issue. Documentation is really, really important. Now, let's see here. So let's say, real world example. Let's say that you're at home and your Wi-Fi stopped working. So a newbie will be like, my Wi-Fi sucks, and start unplugging random stuff and, still broken because they don't know how to fix it. So, but this is how the IT pro will handle it. So first, is this one device or is it all of them? Check, are you connected to the right network, right? That can happen. You maybe are connected to somebody else or a network or whatever. Some things that actually can happen. Then you test, you try another website or application, maybe a different device. Then you restart your router modem properly to see maybe that will fix the issue. Sometimes there will be glitches and just restarting the equipment will actually fix that issue. And then if it's still down, then maybe you call the ISP or check for outages online. Those are things that maybe you can do, right? So that's what the IT Pro will do. Now, so quick recap, right? You start with identifying, you gather the information, you test the solution, confirm the fix, and escalates if needed. That's what IT Pro will do in a situation like that. Now, I want to say that this mindset is actually one of the most valuable things that you can build early in your tech career, because tools will change, tech will evolve, but problem solving is something that's always going to be there. So next time something doesn't work, just pause, take a break, walk through the steps, and train your brain how to work like an IT pro, okay? Master this and you're already ahead of most of the beginners. Now let's bring it home real quick with a quick self-check. And what's coming next in the series? Great job making it this far. Now that you understand the basics of IT, computers, devices, and data, it's time to test what you've learned. I've pinned 10 self-quiz questions in the comments. Drop your answers below in a single comment, 1 through 10. I will personally review your answers and provide you with your score, and maybe even a tip or two. And you might ask why? And the answer to that is because this is just not a regular video. This is a course to help you and to push you to actually apply what you actually just learned. Now, what's coming up next? In part 2 of this video series, we're diving into infrastructure and how everything works. So if you really want to understand what makes tech work, you don't want to miss it. Now, if you think I've earned it, hit a like, sub, notifications, all that good stuff. Now, let me know in the comments, what was one of the things that actually final click for you in this video, if there was any, or if there's any questions that you still have about this series. I respond to every comment because to me, your learning actually matters. So thank you for being here. See you in the next one. Part 2 is coming soon. JR out.